Alright, so Saxon Course 2, Lesson 21, Prime and Composite Numbers, and then Prime Factorization. So here it wants us to make a list of prime numbers that are less than 16. Now remember, prime numbers are numbers that can only have two factors, 1 and itself. So I'm going to make figure out which numbers are prime. I'm going to first make a list all the way to 16. So 1, 2, make that list. 8, 9, 10, 11, 12, 13, 14, 15, 16. Alright, and I'm going to cross off the ones that are not prime. So 1 is not prime because 1 count is neither prime or composite. 2 is prime, so is 3. 4 is not because 4 is an even number, which means that 2 can go into 4. 5 is prime. 6 is even, again, so we can get rid of all the even numbers because we know that 2 goes into every even number. Okay, 7 is prime. Now 9, we have to think, can 2, 3, 5, or 7 go into 9? Well, I know that 9 can be divided by 3, so it's not prime. 11 is going to be prime. 13 as well. And then 15 can be divided by 5, so it is not prime. So my prime numbers are 2, 3, 5, 7, 11, and 13. This next one wants us to list the factor pairs for each of the numbers. So what factors multiply to equal these numbers? So we have 16, 17, and 18. So 16, I know that there's 1 in 16. 2 and 8, and then 4 and 4. 17, there's only 1 and 17. Those are the only factors. And then 18, we have 1 and 18. It's an even number, so I know that I have 2 and 9. And then I also know that 3 and 6 both go into it. So those are so the only number that is prime is 17. 17 is the only prime number. The next one is list the composite numbers between 40 and 50. So again, I'm going to write those numbers down, and then I'm going to cross off all of the numbers, or I'm going to circle the numbers that are composite, and cross off the numbers that are prime. And 50. Alright, so any number that is even will be composite because 2 goes into every single even number. So I know all these even numbers are composite. Okay, now to look at the other numbers. 41 is going to be prime. 42 is composite. 43 is prime. 47 is prime. And then 49, if you think, 9 plus 4 is equal to 13, so it can't be divided by 3, but 49 can be divided by 7, so 49 is also composite. So these are our composite numbers. Now we want to do that so we can find the prime factorization of each number. So that's what prime numbers multiply to equal these three things. Okay. So first we have 30. And to do prime factorization, there's two ways to do it. I'm going to show both. So if I want to find the prime factorization of 30, I can do it using a factor tree. And what I'm going to do is I'm going to pick two numbers that I know multiply to equal 30. So I'm going to do 3 and 10. So 3 is prime, so I know that's one of my prime numbers. And I'm going to divide my composite numbers till all I have left are prime. So 10 can be divided by 5 and 2. Now 5 and 2 are prime numbers, so my prime factorization of 30 is equal to 3 times 5 times 2. If you notice, all of these numbers are prime, and they have to be prime to be the prime factorization. The other way to do it is to do division by primes. With division by primes, we start with dividing 30, and we need to divide it by a prime number. So I know a prime number I have is 3. 30 divided by 3 is 10. And you think, is 10 prime? No, it's not. So I need to divide it again. And I can divide 10 by 2. 10 divided by 2 is 5. Okay, and 5 is prime. So I know that my 3 prime numbers again are 5, 2, and 3. If you notice, I got the same numbers both times. Okay, so let's go ahead and do this with the other ones. I find division by primes to be easier, but it's your choice, whichever one you think is easier. So I'm going to do division by primes for this next one. I'm going to do a factor tree with this one because it's easier for this. 81 I know is 9 times 9, which then I divide up, and it's 3 times 3. So the prime factorization of 81 equals 3 times 3 times 3 times 3. Alright, 420, it's a large number, so I'm going to do division by primes. So I'm going to do 420. I know that this is an even number. I also know I can divide it by 5. So 5 goes into 42 8 times. That's 40. 2 left over. 5 goes into 24 times. Okay, divide it again. And I can divide 54 by 2. 2 goes into 8 4 times. 2 goes into 4 2 times. I know I can divide that again by 2. 2 goes into 4 2 times. 2 goes into 2 1 time. 21 can be divided by 7, and that's 3. So my prime factorization of 420 is equal to 5 times 2 times 2 times 7 times 3. And that's my answer. This next one wants me to write the prime factorization of 36 and 60 and then find the greatest common factor. Okay? So, what I'm going to do first is figure out the prime factorization. With these ones, I can go ahead and use the factor tree. Okay? I had 6 and 6, 3 and 2, 3 and 2. Okay, so 36 is equal to 2 times 2 times 3 times 3. And now I'm going to do 60. 6 and 10, 3 and 2, 5 and 2. So 60 is equal to 3 times 2 times 5 times 2. So if I look, I'm going to circle all the numbers that are common. So 2 is common, and 3 is common. So my greatest common factor is going to be these numbers multiplied. So it's going to be 2 times 2 times 3. So the 3 numbers that are common between them, which is equal to 12. So 12 is my greatest common factor. And that's it for this lesson.